the adult animal at maintenance really will benefit from varying levels. It could be from, it could be up to 10 or 12%. I think they benefit a lot throughout that period of their life by having sufficient fiber and in the right ratios so that they can, when they get to the senior state, the geriatric state, their gut is in better condition, their immune system is more optimal than it would be if they didn't have that.
Hello, everyone, and welcome to the Pet Food Science Podcast, where our goal is to provide information on current advancements and historical progression through the pet food industry to help the entire industry continue to innovate so that we can continue to support the health and well-being of dogs and cats through their lifetime. I'm extremely excited today to have Dr. George Fahey with us, and we're going to talk a little bit about fiber. Now, for most of you, I'm not going to go into a belabored introduction of Dr. Fahey. He is a professor emeritus of animal sciences and nutritional sciences at the University of Illinois at Urbana-Champaign, and he's also the owner of Fahey Nutrition Consulting Incorporated. We all know Dr. Fahey because of his years of input into the pet food industry and into helping to develop the next generation of pet food professionals. And it is truly an honor to have him talk to us again today about fiber. Himself and some of his trainees, such as Kelly Swanson, have been on the Pet Food Science podcast. We've talked about total dietary fiber and prebiotics and postbiotics and probiotics in a series of different podcasts that I would direct you to before. But today we're going to come back to fiber and we're going to hone in on formulations. So welcome, Dr. Fahey. Thanks for joining today.
Thank you, Kate. It's a pleasure to be here.
Well, I was hoping that maybe you can start. I love historical perspectives of nutrition, and you are the fiber expert in the pet food industry. Could you walk us back to when fiber started to be considered by the pet food industry, and then maybe provide a little bit of a progression of what has happened to get us to where we are today?
Okay, sure. I'll try to do that. So in non-ruminant animal nutrition, fiber was not very fashionable, a topic uh, for many years because the emphasis was on nutrients, macronutrients, micronutrients, and most of the research revolved around those. And there was plenty of work to be done in those areas, to be sure. Um, the way that I got started in the fiber in the pet area was actually has to do with the company that you work with, and that was IAMS. And Dr. Corbin started the companion animal nutrition program at University of Illinois in 1973, and we worked together. Even though I was in the ruminant area at that time, we cooperated and actually advised for students that got their masters with us. But that work was more along the lines of it was fairly simple work looking at digestibility, palatability of different types of diets and looking at different ingredients in those diets. And being a fiber person, one of the things that we looked at was the fiber. But in those days, of course, this is before the total dietary fiber. So we had detergent fiber. Everybody remembers Van Soest detergent system of analysis, NDF, ADF, ADL. And so we would measure fiber digestibility, and there were some interesting trends that we saw with different kinds of diets, with different kinds of ingredients in diets. But in the late 80s, about I'd say 87 or 88, Imes was interested in. Of course, they had a very high quality diet that they made, and they hadn't spent any time, as I understood it at the time, on the fiber. But they were very cognizant of digestive health. They were kind of ahead of their time in terms of digestive health, and they were using beet pulp in their fiber formulations, in the diet formulations. And so, but they had no data really to speak of on that. And this coincided now with the development of the TDF, the Prosky TDF system that was designed for human nutrition. But of course, we use that in all nutrition now. And so we had a little better handle on the type of fiber. So I was engaged at that time. I was a staff member at UIUC, and we did quite a large amount of research in the late 80s, early 90s, looking at different formulas, looking at the value of beet pulp in particular, but beet pulp in relation to other fibers like cellulose. And so we started recognizing that there was a soluble fiber component, there was insoluble fiber that seemed to be important in human nutrition. So was that important in pet nutrition? And beet pulp was working very well for them, but they didn't know really why it was working so well. And it turns out that we did a lot of extensive analyses of different beet pulps from all over the globe, and found that beet pulp had just nearly the ideal amount of insoluble relative to soluble. That there was regardless of where you got the beet pulp, whether the beet pulp was when they harvested the beets, whether they put the pulp in a barn so that it didn't get wasn't exposed to the weather, or whether it was out and was weathered, there was still a fairly good ratio of sort of about an 80-20 ratio of insoluble to soluble fiber. Those beet pulps that were preserved by storage, they sometimes had as much as 50% of the fiber was soluble. So they were getting different results with the different beet pulps that they got. Well, that helped to explain it right there, that did you feed one that was 50-50 or did you feed one that was 80-20? Made a difference. And we started looking at other fibers, and they didn't have the same characteristics at all. I mean, you have like wood cellulose was a popular fiber for pets for many years, and it still is used, and it has a role. Totally 100% insoluble, pardon me, and almost 0% fermentable. So all it was doing was having a laxation effect. It did not have any physiological effect on the microbiota in the large bowel, which we know now to be important. Back then, we didn't know that to be important in the dog and the cat. But as we looked at this, we found that digestibilities were pretty high. And then when we started tearing these things apart and looking at what type of fermentation patterns occurred, and this work would have been done in vitro, we saw huge differences. So from there, that was kind of the springboard of how I got started in this. And then over the years, we've looked at just many, many different types of fibers, and basically came up with the fact that one fiber, even beet pulp being almost the gold standard, you might consider it that. But beet pulp is not always that available. So what other fibers can we use? Well, there are any number. But then it became pretty obvious that it was not just one, but the blend of fibers. You can put together a nice blend of fibers that you can that will act in the gut in a way that enhances the microbiota, it enhances the stool quality, it enhances the gut health of the animal. And so that became an area of interest of these different blends. Well, then in 1995, comes along the prebiotic, the Gibson and Rutherford paper, showing that there was these things called prebiotics. And that was kind of revolutionary. But these were things that we had been using in animal nutrition. The fructans are present in any number of, of commodity ingredients. The galacto-oligosaccharides, there's 4 to 5% of the dry matter of soybean meal, which was very heavily used in pet nutrition. 4 to 5% of the dry matter of soybean meal is galacto-oligosaccharides. And so that added yet another dimension to the thing. And the good thing about prebiotics was that you didn't have to add 10%, that 0.5%, 0.8% had a very marked effect on the physiological outcomes that one could measure. And then, of course, at this particular time, the microbiota field got really important. And so you were able to take a look at the microbiota and see what actually happened to these genera. Well, these genera were very positively impacted by these. And so that kind of takes us through even today, where we do really advanced microbiota work as affected by ingredients that are in the pet diet. And then, as I say, these blends and so forth, these are really important, and they have a major effect on the gut health of the dog and the cat. We also learned kind of the hard way that cats are not dogs, and in so many ways. But in fiber, we had this brilliant idea that we had this concoction that we made up that just worked beautifully in dogs, and we fed to cats, and they had explosive diarrhea. And so soluble fiber in cats, you have to be very cautious. Dogs can tolerate a lot of soluble fiber. Cats, not so much, and they manifest it in a way that's not very pleasant to have to deal with. And so those species differences, the blend that works for dogs, it's not necessarily the blend that works for cats. Then to take it one step further, we now have, life stage. We have the young animals, we have the adult at maintenance, we have the senior, we have the geriatric. There are differences in how the animal at those life stages react to fiber. And then the next part of that is that, of course, now we know that, especially with pets, but with many animals, nutrition and health are linked at the hip. And so there are so many nutrition and health platforms that are impacted by the fiber component, because 70+% of the immune system is in the digestive tract. So when you're affecting the digestive tract, you're affecting the immune system. And here now, of course, we know with prebiotics, probiotics, symbiotics, postbiotics, we know that even the gut-brain axis is impacted. Our anxiety and mental acuity and so forth are impacted by those things that are generated in the large bowel. And a large amount of that is affected by the fiber component, because that's the good stuff that's being fermented. We do have other things that escape, like amino acids and so forth, but we'd rather not have those. Those are fermented, but not to good things, not to ammonia and amines and phenols and indoles. Sure, some of these, not all are bad, but certainly not all are good. And so a lot of the good products are that affect the body per se are basically postbiotic type things.
Kemin Nutrissurance is compelled to provide safe and delicious ingredients to improve our pets' food so they can have the best quality of life. Every day, they deliver specialized expertise, innovative products, and unrivaled support through the pet food and rendering value chain. From oxidation control and food safety to palatability and nutrition, all the way through a suite of tailored services that support you from start to finish, we ensure you're getting the most from Kemin ingredients. Kemen is compelled by curiosity to ensure pets around the world are living happy and healthy lives.
So the biggest change is the levels of understanding. So kind of coming from understanding ADF and NDF, which are components of crude fiber. But what really does, neither ADF or NDF gives you any idea about the amount of soluble or insoluble, and also doesn't capture a lot of those oligosaccharides. So I know that our listeners in the pet food industry would all be very, very aware of the move towards labeling for TDF. So maybe a really great place to start is when we think about our total dietary fiber supply, and let's just maybe focus on the adult animal, and then juxtaposition maybe the growing animal and the old animal. But where do you recommend targeting TDF for both dogs and cats? And then we'll kind of rip the layers off as we go down.
With a practical diet, uh, with commercially available ingredients, regardless of their quality, it's almost impossible to prepare a cat or dog diet that has less than 3% TDF. Okay, so there you start. Uh, so, what's the magic amount? What's the magic concentration? The answer is there is no magic concentration. A lot of diets come in between 6 and 8%, which is good. Uh, Depending on the diet matrix, you can go up to 10, 12 without very much problem. If we're talking about an adult animal, uh, let's say a weight control formula, you could go above that if you watch the formulation, if you are careful. So the animal can tolerate a fair amount of this fiber, going from a low of 3 to a high of even in the 20s. Some of the weight loss diets have as much as 20+% TDF. Okay. Now with the cat, you have to be more careful. Uh, the cat and its handling of the soluble fiber, you have to sort of err on the side of the insoluble. Okay, because the dog on the other hand can take this fiber, and as long as the ratio is about 80-20 to 70-30, you're going to be in pretty good shape, uh, all things considered, you know. But with the cat, you probably would probably like a 90-10 mixture of insoluble to soluble, and you probably won't go up so high. You probably would keep that at 6, 7, 8%, and not try to exceed the boundaries. I mean, there are cat diets that have more, and I think they get their. I think they are handled okay, but but you do have to watch the soluble very carefully. The cat can handle a lot of insoluble, but much less soluble. Now, regarding the move to TDF, did you want to say something about that?
Sure, you're welcome to say anything that you want, Dr. Fahey.
With regard to TDF, we are moving in that direction. Thank God. After using crude fiber for all these years, that has really set the field back a lot because people it's an analysis that's totally incorrect. The detergent fiber was a big advancement, but as you said, it only measured the insoluble component, and it did not get any of the oligosaccharides, which are soluble fibers. So naturally, it was just it helped some. But the move to TDF is the right way to go, I think, because uh, the one that is going to be used is AOAC 991.43, which is the one where you get the TDF value, the IDF insoluble value, and the SDF the soluble value. And it's not perfect, but we do have nearly perfect TDF analyses. There's actually even an AOAC 2022.01 assay that gets everything, but it is so onerous to do. and so expensive to do that it's just not practical. So the 991.43 is the best one, the most economical one, but you have to recognize a couple things. One is that it does not get all of the oligosaccharides. It may measure, it gets none of the galacto-oligosaccharides. It may analyze for a few of the fructo-oligosaccharides. It gets just a part of the resistant starch. Okay, and today resistant starch is recognized as a fiber component because it's not digested in the small intestine, but rather is fermented in the large bowel. And we even have high resistant starch varieties. Usually these are high amylose starches. So you can have corn, whereas yellow dent number 2 corn would have 9% TDF. One that is bred for resistant starch can have twice that. It can have 18% fiber.
Yeah, maybe one question that the listeners would like to know about. I think a lot of people know about TDF, and you've covered insoluble and soluble. I'm going to get a little bit into these oligosaccharides with you, but can you impart to the listeners how in pet food we talk a lot about starch cook, and that probably gives a little bit of an indication of how much resistant starch you have. But would you like to expand on how resistant starch is present in pet food and how manufacturers should think about that?
Yeah, well, starch is made up of amylose and amylopectin, right? Start out with those are the two components. Starch is all glucose, alpha 1,4 link glucose with alpha 1,6 linkages. Okay, so the amylopectin, which is the alpha 1,4, the alpha 1,6, that's very digestible. That's where you get your very high cook. Amylose, strangely enough, even though it's a straight chain, is less digestible. Okay. And so it is the source of the resistant starch for the most part. Okay. And so what happens here is that you can process, you can cook and all that, but that amylose chain is refractory to a point where not all of it is freed up so that it can be fermented or digested, I should say. It's not digested, and not all of it's going to even be fermented because it's somewhat refractory. Some depends on the source. Again, is it corn or barley or rye or whatever? What's the source of the starch? So the cooking will, and if you have a high resistance starch in the formula, it is hard to say how much of that's going to be cooked. That's still an open question. You just can't say, oh yeah, this much is going to be disappear, or no. That's not the way it goes. So if you are using resistant starch hybrids, high amylose hybrids, it's by far best to do a resistant starch assay yourself. If you, as a pet food manufacturer, are using ingredients that have resistant starch, then do yourself a favor and measure the amount of resistant starch, not by measuring TDF, but by measuring resistant starch. The techniques are very good for that. Okay, so what happens here is that the analytical becomes really important.
Yeah, really, really well. It's I think it's one thing that a lot of people aren't paying attention to is high amylose containing ingredients in their use and how much is actually available to the animal. When I think what's happening here is that you also have some companies that are assuming that it's digestible, and then the animal is going to absorb glucose, or disaccharides. And I'm not sure that's wholly happening. And so I think an appreciation of resistant starch in products is important. You covered.
Yeah, and then the gelatinization or the cook, as they say, uh, you get values of what, 88 or 90, or sometimes you get in some of these new niche diets, you get 97% cook. And so that may be good or maybe not. If you have a lower, it's indicative of the amount of starch that's not cooked and the amount of resistant starch. That's not the way to calculate the resistant starch, but just the practical method of gelatinization is kind of indicative of how much might be in there. Okay. And so it's good to know those things to move forward. And because if you have more resistant starch, then guess what? You just don't have to add as much fiber, right? And you have a very good fiber because resistant starch is one fiber that produces the most butyrate, which is one of the short chain fatty acids that we really look to enhance the health. And so you can maximize your formula, or optimize, I should say, by knowing those things.
Fantastic. We've covered TDF and the insoluble to soluble, and the last component to discuss here is the particular oligosaccharides and why you might recommend their inclusion in different types of formulas. These are available in different types of ingredients. So if you wouldn't mind giving the listeners a little bit of an idea too, if you're looking for this oligosaccharide, you might be able to find it in these ingredients as well. Would you mind commenting on that?
With regard to prebiotics, there's three that are kind of accepted as just three that are kind of accepted as the gold standards. One would be the fructans, and those would be the inulin. It would be oligofructose, which is just a hydrolysis product of inulin, and it would be the short chain FOS, which is a synthetic product. It only has it has DP. I forget the DP numbers, but it's nevertheless it's a much shorter chain, much lower molecular weight, and it's synthesized from lactose and monomeric sugars by a certain bacteria that produces that. So those are the three sources, and they are all available commercially. Then we have galacto-oligosaccharides. The ones in soybean are stachyose, raffinose, and verbascose. And then there are plenty of synthetic galacto-oligosaccharides that are manufactured again by taking monomers and converting them to a oligomer, at least by certain bacteria. And those are available. And then the lactulose is the third one, and lactulose is a stool softener for humans, but the important one there is that it's got galactose in it. Now, people are trying to expand that list because we know that, for example, again in our work with beet pulp, we found out we would use beet pulp as a control in our diets, and then we'd try to see how fructans and galacto-oligosaccharides would work, and we didn't find much difference. And then we figured, gosh, the beet pulp has prebiotic activity. The fiber fragments of beet pulp affect the microbiota. And we went drilled down and looked at that, and lo and behold, it was very good. So that was an additional benefit of beet pulp, that it had this prebiotic activity, as do several other fibers. So the ISAP, the International Scientific Association of Prebiotics and Probiotics, they just met this year, and one of their sessions had to do with candidate prebiotics. And I think what we're going to do is we're going to see the candidate prebiotics really flourish now, because people have been looking at these different fibers and finding that they have prebiotic effect according to the standard definition for prebiotics. Now, as far as sources of these, like galacto-oligosaccharides, I told you about soy, and a lot of legumes and will have galacto-oligosaccharides, not near as much as soy. Fructans are in these kind of weird plants like leek and chicory and things that aren't necessarily commodity ingredients in pet food diets. in pet diets. And so, but these are very available in pure form, in nearly pure form, so they can be added to the diet in that way versus trying to assume that some ingredient is going to supply, because the ingredients probably aren't going to supply so much of the fructans. But but as I say, the with the TDF, they don't capture the fructans. But what you can do is you can uh, get the TDF value, and then once you know the purity of the fructan that you're adding, that's all you need to do is find out what the purity of the fructan that you're adding is from the manufacturer, and they should give that to you. There's certain ones that are 95, there's certain ones that are 90, there's certain ones that are 75. Okay, and then you just add that on. That's an additional amount of fiber in the diet. So if you don't want to go through all the hassle of measuring oligosaccharides by themselves, you can do that little calculation with that information that you got, and then just add that on and figure out, have a better, even a more accurate value for the quote unquote fiber in the diet. So um, that's kind of the way that I think that it works out the best.
It's time for our famous three. At Allura Pets, our commitment to biotechnological innovations empowers you to craft superior products that redefine pet wellness standards. Whether enhancing nutrient bioavailability, promoting gut health, or boosting immunity, our science-backed solutions give your formulations a competitive edge in the pet market. Trust Allura Pets to deliver scientifically proven ingredients that elevate your portfolio to new heights. Visit us at www.allura.bio/pets to learn more.
Well, that's fantastic. Thank you. We've had a very, very deep conversation on fibers. And so maybe I'll ask you some really broad questions at the end here for why companies really do need to think about TDF. So, do you agree that stool quality is a primary outcome for the dog or cat owner?
Agreed, of course.
Okay, so I think that's probably a primary insight to GI health.
Sure,
Yeah,
sure.
and maybe, of course, I think we should clarify there's a spectrum of healthy stool quality too. So, not too loose, but soft is okay. Not too hard, but well formed every day is also okay if that's the pattern for the dog or the cat. Um, what would happen to an animal that got insufficient dietary fiber from birth?
An animal that got insufficient dietary fiber from birth would live a long time. They, relatively speaking, I mean, they would not have the best uh, large bowel health. Uh, they probably would not have the best or the optimal immune system. They may or may not have a very good stool quality, although they could have, uh, a reasonable one. So it's not like a life or death thing where they don't they don't they would not live if they didn't have it. You remember that mother's milk is high in oligosaccharides.
Mhm.
That is the fiber that's present in the mother's milk. So they're getting fiber to start out with from the very first time they're born, right? And so they would be weaned, and they would be having pretty much enough of these oligosaccharides to supply the necessary fiber. Then what's the next step to the how much fiber are we going to add? And so if there was none, again, I don't think they would be in nearly as good a health as an animal that had adequate fiber. But it would take a long time to manifest itself, I think.
Yeah, and I think too, you said it earlier, there's almost not at least a commercial extruded diet on the market that doesn't have about a minimum of 3% TDF. So it's very difficult to avoid eating any fiber altogether.
And even in the wet diet format, even the wet diets, you have your thickeners, your carrageenans, and those types of things, gum arabic. Those are fibers. So those are present in the wet diet, and so you you have fiber from that. So yeah, it's darn near impossible not to have some.
Yeah, absolutely. It's in a lot of the ingredients, the vast majority of ingredients that we use. So then on the flip side, who in the dog and or cat population, I'm sure you can separate those species, may benefit from the high end of total dietary fiber, and you might want to clarify whether that is insoluble or soluble as well.
Well, I think the probably the adult animal at maintenance really will benefit from varying levels. It could be from, it could be up to 10 or 12%. I think they benefit a lot throughout that period of their life by having sufficient fiber and in the right ratios so that they can, when they get to the senior state, the geriatric state, their gut is in better condition, their immune system is more optimal than it would be if they didn't have that. Because when they get to that state, then you have to worry about their intake may drop off, or we don't want them to be losing lean muscle mass and all this type of thing, and their bacterial profile or microbiota profile can be less than it was, that type of thing. So you can look at that state there, the elderly animal. You can put together a formulation that's better than you would have for the adult. You probably lower this somewhat because they may not handle it as well as evidenced by poor stool quality, okay, and certainly poor microbial ecology, and so you might have to lower the amount. You might have to change uh, the ratios of insoluble to soluble. Again, sometimes elderly animals don't react very well to soluble, just like the cat in normal. They you can put too much soluble in, and then you can have a problem. So you might lean more towards the insoluble, but you would change it from an insoluble that was 10% fermentable to an insoluble fiber that might be 50% fermentable. Okay, just so that they got the short chain fatty acids, so that they can maintain their gut integrity, so that they can maintain optimal immune function, that type of thing. So that's how I would view that.
Fantastic. And one last question. It's personal fiber question, not personal for me, but I want to know what your most favorite food that is high fiber is and how often do you eat it?
I'm a person that likes vegetables very much. I like legumes. I like beans. I like peas, and I eat a lot of those. I like those as a part of the diet. So that's not a stretch for me to have those numerous times a week, and so and they have a good ratio of insoluble to soluble. Um, but I think those would be that would be the main uh, category of food that I would use to supply the fiber. I like, again, broccoli, all kinds of vegetables. I could live on vegetables myself, but yeah, I like those. So
Oh, I would pick the beans over the broccoli. I think that my favorite soluble fiber source, I really, I don't mind vegetables either, but I probably index far higher on fruit.
fruit, yeah, yeah, I like fruit too. Sure, yeah.
So I would always, and this could be a topic of another podcast, but I imagine my grandmother always said that she lived to 99, and she said that it was because she ate an apple every day. So I might add the question of, did she just have this really great soluble fiber intake throughout her life? Um,
Or did she have good genetics?
and probably had some pretty good genetics, because I think she lived with a smoker for 50 years. So
Oh,
she got over that and lived to 99. So maybe the apples and the genetics combined. It's always a genetics by environment equation, right?
there you go. Yeah, that's right.
Well, thank you for coming back to the Pet Food Science Podcast. It's always a pleasure to talk to you. Such a wealth of knowledge. Thank you for being part of the pet food industry and always sharing your knowledge and insights with all of us whenever we ask. So with that, thank you, and thanks to the audience.
Thank you very much. See you later.